Let us study about redox reactions. Now, it's there in the name itself, and if you look at it closely, this is actually a reduction plus oxidation reaction taking place simultaneously. Okay, so redox reactions are those in which one species donates electrons while the other species accepts the electrons. Okay, so remember, redox reactions are those in which the electrons are transferred between two different species or two different molecules. One species donates the electrons while the other one will accept the electrons. Okay, so that's how it got its name, redox. It's a combination of reduction and oxidation reactions taking place together. Let's look at some common examples where we can see oxidation and reduction reactions taking place in a single reaction. Now, rusting of iron is a very good example where we can see a redox reaction taking place. Let me write the reaction. So iron reacts with oxygen present in the air, which is a gas, to form iron oxide. So if I balance this equation, so I'll have to put 2 here. So 4 moles of iron combines with 3 moles of oxygen present in the air to form 2 moles of iron oxide. Okay, now let us see why this reaction classifies as a redox reaction. So if you look at iron here, okay, so there are 4 moles of iron atom. Okay, now iron does not have any charge on it. Iron is not having any charge on it, so the charge is 0. Okay, now if you look here, which is Fe2O3. Okay, so we know that oxygen usually exists as the oxide ion, which is O2 minus, which is O2 minus. Now because there are 3 oxygens here, so 3 into 2 will give rise to minus 6. Okay, so oxygens have a total charge of minus 6. So iron here is actually existing in ferric state, which is 3 plus. Because there are 2 atoms of iron, each of them should be plus 3. Okay, so in the course of this reaction, the iron atom, which is in its neutral state, has got oxidized because iron has lost 3 electrons in this process, and those electrons are picked up by the oxygen atom. Okay, so in the reactant side, iron is in its neutral state, but over the course of reaction, the iron atom gets oxidized. Which means it has lost its electrons. Okay, and by losing electrons or by donating electrons, iron is reducing the other atom, which is oxygen. Okay, now because it is reducing the other species here, iron is also called as the reducing agent. Okay, so any species that gets oxidized and thereby reduces the other species is called a reducing agent. Okay, so those molecules that get oxidized are actually acting as reducing agents. They themselves get oxidized, but in this process, because electrons are lost, this helps them to reduce the other species. Okay, now again, if we look here, oxygen does not have any charge. Okay, so oxygen does not have any charge, But here, as we know, oxygen is existing as -2 because iron is in +3 state. Okay, so oxygen has gone from 0 or O to O2 minus in this reaction, which means oxygen had to gain 2 electrons in this process. Oxygen had to gain 2 electrons to reach this state. Okay, now because oxygen has gained 2 electrons, we can say that the oxygen atom is reduced. We can say that the oxygen atom is reduced, but it is acting as the oxidizing agent because it has oxidized the iron atom in this process. Okay, by itself getting reduced, oxygen has oxidize the iron atom. Okay, so that's why this is an example of a redox reaction, because one atom is oxidized and the other atom has reduced. Okay, so oxygen has gained the electrons, but those electrons are coming from the iron atom. Okay, so this is a classical example because we see both the reactions. So this can be called as the oxidation half reaction. This is the reduction half reaction. Let's look at another example. Zinc, which is designated Zn, combines with silver sulfate to form zinc sulfate plus silver. Okay, now this is a displacement reaction in chemistry because zinc is displacing silver. Zinc is displacing silver, thereby forming zinc sulfate plus silver. Zinc sulfate plus silver. Okay, now this zinc gets converted to Zn2 plus. Okay, so if you look at zinc sulfate is a ionic compound because zinc has lost 2 electrons while sulfate has gained 2 electrons. This is how this bond forms. Zinc will lose 2 electrons while oxygen will gain those 2 electrons, and this is how zinc sulfate is formed. Okay, now so zinc in the reactant had no charge on it, but when it has become the product, it has lost 2 electrons. Now this is the oxidation half reaction. This is the oxidation half reaction wherein zinc is oxidized but is acting as the reducing agent, because by giving or donating its electrons, it is trying to reduce the other element in this reaction. Okay, now if you look at silver, so silver sulfate is 2 minus, so this will be 2 plus. So because there are 2 silver atoms, it will be +1 for each. It will be +1 for each. So plus gains a single electron, and it gets reduced to atomic silver. Now because this has gained electrons, this is called a reduction reaction, or this is the reduction half reaction of this entire reaction. Okay, now silver is again the oxidizing agent because it is trying to oxidize the other atom, which is zinc. Okay, this is another example of a redox reaction where we see both oxidation and reduction simultaneously taking place.